We're moving on to our last major building block that we need to discuss. So already done mux and the decoder, and now we're moving on to an encoder. So the last time we discussed the decoder, we talked about it being somewhat of like an expansion. That we have a small number of inputs, and then we're going to use that small number of inputs to drive into a larger number of outputs. The examples we had given were we really focus on a line decoder to say you had, let's in this example, 2 to 4, you had two inputs coming in, and you could generate the four midterms. The other way we kind of discussed it was we talked about a 7 segment LED light, and we can have that a number we wanted to show up on that light. That would be the input, and the output would be the 8 outputs to turn on the actual digit. Well, an encoder kind of works in the opposite direction. The encoder is looking at having a larger number of inputs and going down to a smaller number of outputs. How would these items be used? Well, sometimes they can be used in conjunction with each other to say maybe we're transferring data from one side of a chip to another side of a chip, or just transferring between two actual chips. We may not want to run, a lot of lines. Every line that we put out is more costs, a bigger board. There's a little bit of conflicts that can happen across electricity, noise in the lines. So we kind of want to reduce that. So we might have that type of setup done. So an example here would be, let's say we wanted to have that output of that 7 segment decoder go from one side of a chip to another side of the chip. That would be the input to this encoder. The encoder would give us a number, and then we send that number to another decoder to get back to the original output. The other way it could be used is if we had, let's say, a mechanism to count how much money has come into a vending machine. Well, the inputs might be we have a nickel, a dime, a quarter, a dollar. And those are 4 separate inputs, but we want to get it down to having 4 combinations with just 2 bits. So we can use an encoder in that sense. The one that is shown in our book is a special type of encoder. It's called a priority encoder. So priority encoders, or encoders in general, go from 2 to the n to n. So like 4 to 2, 8 to 3, 16 to 4. So the opposite ways of the decoder. But when we look at this, we kind of want to discuss, what does priority mean? Priority is who has the right to access first. So let's give an example. Let's say we're on the street. We have a car A, a car B. Well, what's controlling who has access to crossing that intersection? Well, we have traffic lights. So if the A has the green light, it's able to cross the intersection. B has the red light, it has to wait. So A has more priority on this street. But we can have a C car coming through, and this C car is an ambulance or a police car, some type of emergency service. Well, what happens in this case is we say C cuts to the front. We're going to let that ambulance, that police car, if the lights are flashing, for it to move through the intersection. So it's able to jump ahead of A and B. So this kind of sets up our priorities. So let's say, how do we draw this out? So we have a 4 to 2 priority encoder. Our inputs, I'm going to label them as X0, X1, X2, and X3. And we're going to generate 2 outputs, an A and a B. Now, the way I'm going to set this up is I'm going to have 0 be the highest priority. It's the first number that would come, in a number line. And then we're going to go down to X3 being the lowest. So this is setting up a ranking system for us. And what I want to view is A and B. We're going to view A and B as a number. So if I said the output is, for example, I'm looking at X0, I want this 0 to be represented as A and B, so it'd be 0, 0. Or if I said X1 needs to, be the one to drive through that intersection, I want it to be represented as A and B as 0, 1. All right, so let's start drawing out a characteristic table. In this characteristics, we're doing the X3, X2, X1, X0 as our inputs, and A and B as our outputs. Now, the way the priority indicator encoder works is whoever has the highest priority gets to go first. So, example, let's take this as I have, the ambulance, you know, two cars, the setup we have. Well, the ambulance goes first. So, as long as it sees a one, the ambulance doesn't care if anybody's waiting at the intersection, it gets to go through first. So, we're going to use X's here as our don't cares. So A and B, I want it to be represented as the digit of which input has a one on it. So we're going to say that's 0, 0 to give us, the number 0. Now, if there was no ambulance on the street, then it's who has the green light. So let's say X1 is the car with the green light. I don't care if there's other cars waiting. The car with the green light gets to go. Well, that would be the number 1, so that's the 0, 1. So now we go down. There's no 0, there's no 1. So now it's time for X2. X2 is the one that gets to get set. So it goes to 1, 0. And then last would be X3. It'll be 1. And then everybody else has to be 0 in order for the 3 to work. So that gives an idea of how this priority works. Now, a big item is working is this is all assuming the priority indicator has at least one digit being a 1. Well, what happens if all of them are zeros? Well, if all of them are zeros, we need to know what would need to occur. So we kind of do not have this input of what happens if everybody is a 0. So a lot of times you would see that these priority indicators have a third item. Let's call it a C. I like to kind of, instead of viewing a C as saying there is input or not, you kind of think of it as kind of like an on symbol, where an on would be some X input is high. Okay, so let's put this C here, or like I can refer to it as being like on. Well, if we're all zeros, this on signal would be a 0. And we really don't care what the X, the A and the B is going to be because nobody is actually on. You don't need to even look at the output. And then we would put all the rest as being an item on. So let's kind of give some context to this on. The way the on would be is, think of it as like we have a door that has like on a motion sensor, like you're going to go into like the grocery store. If nobody is standing on the mat to open up the door, you want the door to be closed. We can kind of say like this X0, X1, X2, X3 would be, okay, which door did it come in? Well, once I see, oh, I need to open the door, then I can look at A and B and kind of figure out who needs to come in. So that's a little bit of the setup on how this encoder will work. Now, the last thing you got to do is you got to build the priority encoder. And if we're going to build this, then what are we going to do? We got to make K-maps for each of these outputs. So I'll make a K-map for A. I'll make a K-map for B. And I'll make a K-map for C. Now, the only thing you got to, it's just pretty straightforward. You're just going to take the information and pull it down. But the one thing you got to remember is you're going to have to expand out the don't cares. So like, for example, let's say we're only looking at the input for A. We know that has to be 0 for 1. X0 is a 1 and the rest are don't cares. Well, that has to be expanded out to B. You need to do every combination. Now, this is going to be quite a bit of combinations, because this is 1, 0, 0, 0. It's also a 1, 1, 0, 0. It's also be a 1, 1, 1, 0, a 1, 1, 1, 1. Then it could be in any combinations of ones and zeros. So it could be like example 0, 1, 1, 1, 0, 0, 1. So you have to do all combinations. So that's just a little thing to be cognizant about when you fill this out. Now, you don't necessarily need to write it all down as in a truth table. You can kind of think about it as you're filling in the K-map. So here, let's say we have this K-map. And what I'm concerned about is I'm really looking at x0 needs to have a 1. So if I look at x0, where does x0 has ones? It's going to be these columns. And because those are the columns, I don't care what any of the other values were. I would just fill in a 1 for all of those locations. So let's go down one more, and let's talk about the next input, which would be a 1, a 0. Again, x a is 0. So we have 2 don't cares. Well, let me do this in green here. I'm looking at 1, 0. Well, I find 1, 0 in terms of x1 and x0. And since I didn't care about x2 or x3, those were going to be the locations where I put all my, oh, I'm sorry, these should all be zeros. I don't know why I put a 1, but we will fill in the K-map correctly. All right, so just pay attention to, don't cares. They got to find the don't cares on the input are not X's. They are ones and a zero, so you got to fill those in. All right, so that should give you an idea of how to do a priority encoder.